All right, guys. So you should have gotten those 6 problems uploaded by now. And I want to look at the triangle side splitting converse theorem. All right. So it is in your book if you want to check it out as I'm writing. Let me look at the page number. It's on page 776. And it is just going backwards, all right? It's just going backwards from what we said before. We talked before about if these two lines are parallel, then their sides are proportional, the parts that are cut into it. This is just going backwards. This is just telling us that if our sides are proportional, AD, DB, AE to, oh, did I write that wrong? It should be EC. I did that one wrong. Hold on. It should be EC. So it's just telling you that if you have that proportional relationship, then you can back up and say that these two lines are parallel. And that's important when we write our proofs. I know you all are so excited. This is good when we write our proofs, when it's asking us if we have lines that are parallel. So if you can prove they're proportional, then you can say, based on the triangle side splitting converse theorem, that the two lines are parallel. Okay, so that was the second theorem. The third theorem in here is the trapezoid side splitting theorem. So it's basically going from a triangle to a trapezoid. And this one is on page 777. All right. And what it's telling us is that if we have a trapezoid, okay, and we have the fact that we have a line that divides the legs into two segments, all right? And when it does that, if all three parts of these, if they're parallel, all right, so notice that I have all of these as parallel, then we can say that these sides are proportional. So what you have here is you have, when you do that, you would have AB, so I'm doing basically top trapezoid. So I have AB is going to be equal to PQ. Okay. Now, you can also find out other parts. So if you're asked to find out like a base or something like that, if you're given one base here, you can also go with the same idea of similitude here. So let's say this is, if you're asked to find a base, you can say that trapezoid A, B, E, D is similar to A, C, F, D. And then you just go back to our similitude theorems and you can find that ratio. Like, how was it dilated? Was it gotten big? Did it get bigger or did it get smaller? So this is going to allow you to find values for each of these sides. And once again, it's just setting it up into that proportional relationship and then solving for your unknown. All right, so I want you to try this. We're not going to do any proofs today. We'll save that for tomorrow, okay? So what I want you to do is I want you to try to do numbers. Make sure I get the right ones. I don't want to give you proofs today. I want you to try number 9 on page 779. Okay. And then numbers 14 and 15. Okay, now I don't know where you're at in class right now. I'm going to try to hop on to be there in case you have questions. But I would like this today. If not, then this is going to be your homework. Okay, and it needs to be turned in online. All right, so make sure you turn it in online as well. The videos are there for you to go back and look for. I'm going to be on, hopefully I'm going to be online to help you out if you have questions. So here are the 3 theorems that we looked at today, and they're all on one page. I'll upload a screenshot as well. This was your classwork. All right, this is your homework. Remember, you can always Google the topics, so you can Google any of these theorems, and you can probably come up with a lot more videos that are better than my videos by any means. All right, so we'll go from there. All right, any questions or anything on that? All right, thanks, guys.